Today we will be dealing with physics, and the topic we are going to treat today is current electricity. What is current electricity? Current electricity simply means what? The flow of charge, or what? Charge in what? Motion. Now, when we have flow of charge through a conductor within a closed loop, such is called what? An electric circuit. And under this topic, there are certain terms that we need to know before we move further, and I will put you through all those terms as we proceed. The first is current. Current. What is current? Current is the rate of flow of what? Charge through what? A circuit. The rate of flow of charge per unit time is then what? Current. So current is the what? The rate of flow of charge per unit time. Now, current can be measured what? Directly. That simply means that we have an instrument that can help you measure current directly, and that instrument is called what? Ammeter. So current is measured with an instrument called what? Ammeter. We have different types of ammeter. We have different types of ammeter. We have micro ammeter, we have milli ammeter, and we have what? Galvanometer. Now, micro ammeter is used to measure significant small amounts of current, also milliammeter. But galvanometer is used to measure very little amount of current, and it is about 10 times sensitive, or I would say 1,000 times sensitive than what? Than milli or micro ammeter. That shows you how sensitive it is. It can measure very small amounts of current, and not only measure it but tell you the what? Direction of flow, either to the left or to the right. So it will deflect either to the left or to the right. Now, the second concept we need to also talk about is what? Potential difference. Potential difference, what we call PD. What is potential difference? Potential difference is the work done in moving a unit charge from one point of the circuit to another. The work done in moving what? A unit charge from one point of the circuit to another. Also, potential difference can be measured directly with instruments called what? Voltmeter. So we use voltmeter to do what? Measure what? Potential difference. Then the next concept we need to talk about is what? Resistance. Resistance. Now, just as the name implies, when you hear the word resistance, what comes to your mind? Just as usage in English, that is also how it is used in this topic. Resistance simply means what? Opposition. So resistance in this concept is what? Opposition to the what? The flow of what? Current in a circuit, and the unit is what? Ohms. Resistance is what? Measured in ohms. Don't forget, resistance is what? Measured in ohms. So any device that opposes the flow of current is called what? A resistor. A device that opposes the flow of current is called what? A resistor. Why the inherent property of that device that opposes the flow of current is called it what? Resistance. So now you know the difference between what? A resistance and what? A resistor. Don't forget that. I will ask you in the course of this class. Okay, now these three concepts will form our major background to what we are going to do today. Now, the next thing you need to know is Ohm's law. Ohm's law. Ohm's law is one of the principles we use whenever we are talking about direct current. It is one of the most important principle in electricity, especially when you talk about direct current. It helps us solve a lot of problems. It helps us work out a lot of issues, and without this law, a lot of success we have in this field wouldn't have been possible. Now, what is Ohm's law? Ohm's law said that the current passing through Ohm's law states that a current passing through a metallic conductor is directly proportional to the applied potential difference, provided the temperature and other physical means remains constant. I take that again. Ohm's law said that the current passing through a metallic conductor is directly proportional to its applied potential difference, provided that the temperature and other physical means remains constant. That means Ohm's law said that the current is what directly proportional to the what applied potential difference, provided that the temperature and what other physical means remains constant. So from here we have, if V is directly proportional to I, don't forget that in mathematics whenever we have this sign we do what, we introduce constant and to change it to what, equality. So that means V will be equals to what, IR, where our R is our constant of what, proportionality, and it is called what, ohms. Our R is in what, in ohms, which shows the what, the resistance of that what, material. Now have this, don't forget this, that every material has its what, conductive ability. That simply means the ability of any material to conduct current varies from one material to another, and this variation is due to what, it what, resistance. So a material with a very high resistance will do what, will be a poor what, conductor, while a material with very low resistance will be what, a good conductor. Don't forget what I just said, that the higher the resistance, the what, the lower the what, conductivity. Don't forget that. Now Ohm's law is not a law that define anything in electricity. It is only within what, a metallic conductor that this law is what, obeyed. That simply means there are other conductors that doesn't obey Ohm's law. Like transistor, for instance, does not obey Ohm's law. Semiconductors does not obey Ohm's law. Radio valves does not obey Ohm's law. Neon gas and acid does not what, obey Ohm's law. So these are what limitation to what, Ohm's law. Ohm's law is only for what, a metallic conductor. Don't forget that the Ohm's law is what, only for what, a metallic conductor. Okay, so now let's see what we can do with this formula. So with this formula we have V equals to IR. We can use this to find resistance if we know the voltage supply and the what, the current flow within that material. You can also use this to find what, the potential drop at what, any point in what, in any material. We can also use this to do what, determine the current flow if you know the what, the voltage supply and the what, resistance of that material. So let's see how we will use this mathematically to solve problem.